welcome back to another ampdyno video. Nice to see you again. Today I have another old school amplifier which is made by Infinity and the model is Kappa 202A and the power ratings are 200 watts by 2 into a 4 ohm load of continuous power and 300 watts by 2 into a 2 ohm load per channel. During the ampdyno the Kappa 202A was very efficient, so I decided to do a 2 ohms mono test. Regarding to some manuals I found, the amplifier was made in 1996. This amp is also subscriber supported. Usually I show up some pictures of the internals, but this time I wasn't able to open the amplifier. The amplifier is a kind of one-piece heatsink design. That means you have to lose all screws and slide the mainboard off. But that wasn't possible because of the insulators of the transistors. They were like glued on the heatsink. As I told you before, this amp is not mine and I didn't want to damage the amplifier or damage the insulators. You can get into further trouble or problems, and that was something I just wanted to avoid. You can adjust the bass boost frequency from 20 to 80 Hz. And there's also low pass and high pass filters from 32 to 320 Hz. There's a switch, stereo or bridge mode if you want to bridge the amplifier. The input sensitivity of the amplifier ranges from 0.25 volts to 9 volts. Now it's time to zoom to the scope and start the ampdyno.
The Infinity Kappa 202A is connected to the dummy load and I'm starting with an 8 ohm mono load to get the output power into a 4 ohm load per channel, both channels driven to full power. Now I'm starting with a continuous power test with 1 kHz. Screenshot. And I got a peak voltage of 80 volts. With 80 volts, the amplifier delivers a bridge mono 8 ohm output power of 410 watts. And that means I got 205 watts per channel into a 4 ohm load, both channels driven into full power with a 1 kHz signal. And now I'm having a look at the amplifier's efficiency. And it pulls 43.8 amps. I calculated an efficiency of 68.3%. And now I'm testing dynamic power with 20 cycles. And we have all cycles at the same voltage level. Looks okay. You have 80 volts. It's the first cycles. And here we have 82.4 volts. I go to the last cycles. Small amount of clipping here. I would say let's calculate with 81.6 volts. Now I got 213 watts per channel into a 4 ohm load with 20 cycles. Testing with 8 cycles. Got it. Yes, we got a higher voltage. We got 84 volts. And on the last cycle also. So we calculate with 84 volts, 226 watts per channel into a 4 ohm load. Now I'm testing the maximum output power with 1 cycle, but with a dirty signal we have some kind of distortion here. But we have a higher peak power, so I calculate with the highest peak. And that's 88 volts. With 1 cycle and a dirty signal I got around 248 watts. And the next continuous power test, but this time with a 50 Hz input signal. Have a look. Great, the amplifier delivers also 80 volts. The amplifier has a great power linearity. The amplifier delivers also 205 watts into a 4 ohm load per channel, both channels driven into full power with 50 Hz. And now I'm switching to 2 ohms per channel. First test, 1 kHz continuous power, both channels driven. And I got a peak voltage of 72.8 volts. With 72.8 volts, the amplifier delivers 679.6 watts into a bridged mono 4 ohm load. That means 339.8 watts into a 2 ohm load per channel, both channels driven. So almost 340 watts into a 2 ohm load per channel, or 680 watts into a bridged mono 4 ohm load. Let's have a look how many amps the amplifier pulls out of my power supply. 76.6 amps. I calculated an efficiency of around 65%. The amplifier's power linearity was great at 4 ohms per channel, and now let's have a look if it's also great at 2 ohms per channel. Screenshot. .8 volts, so we have the same output power. The amplifier puts out the same power with 50 Hz as it puts out at 1 kHz. Not bad, very good power linearity. Dynamic power test, 2 ohms per channel, 20 cycles. Let's have a look. All at the same voltage level. Great. Does it look clean? Yes. 74.4 volts at the center cycles. The last cycle shows signs of clipping, but I take the peak voltage. So we stay at 74.4 volts. I can adjust it a little bit lower, but this will take time and I got no time. I just want to finish the videos. Okay, let's be fair and let's calculate with 73.6 volts. At the lowest cycle, the amplifier puts out 347.3 watts. And on the highest cycles, we have 354.9 watts into a 2 ohm load per channel, both channels driven into full power. 1 kHz burst test with 8 cycles. Here we have 77.6 volts. Also 77.6 volts. Also 77.6 volts. The amplifier delivers 386 watts per channel into a 2 ohm load, both channels driven into full power with a burst signal of 8 cycles, 1 kHz. And now I'm looking for maximum output power with a little bit distortion and a dirty signal. So we have almost a clean signal. I'm going to take the peak voltage. That's 81.6 volts. The amplifier puts out mono 4 ohm 853.8 watts or 2 ohms per channel, 426.9 watts. So we have an efficiency of more than 60%. I heard a lot that these amplifiers will not run mono 2 ohms. So continuous wise it will not, because the amplifier is fused with 80 amps. So I cannot do a continuous power test, but I will try a dynamic power test mono 2 ohms, 1 ohm per channel, and the amplifier puts out some voltage. And let's have a look. All cycles, same level. First cycle has an output voltage of 59.2 volts. Then we get a little higher, 60.8 volts. I go straight to the last cycle. There we have 60.8, 61.6 volts. At the lowest cycle with 59.2 volts, the amplifier puts out 438.2 watts into a 1 ohm load per channel, both channels driven into full power. And on the highest cycle with 61.6 volts, the amplifier puts out 474.4 watts. And now burst power test, dynamic power with 8 cycles. We have an output voltage of 64 volts. Go to the last cycles. Also 64 volts. Yes, we stay at 64 volts. Wow, that thing is great. At 2 ohms mono, the amplifier puts out a little bit more than 1000 watts. It puts out mono 2 ohms, 1024 watts. That means exactly 512.1 watts into a 1 ohm load per channel, both channels driven into full power with an 8 millisecond burst input signal. I'm trying to squeeze out the maximum output power for just 1 millisecond. That is peak RMS output power. Let's have a look. This one is not too dirty. Distortion here, clips there, and I will take the peak voltage. We are at 75.2 volts. That's impressive and amazing. The amplifier puts out 1414 watts. Mono 2 ohms for 1 millisecond or 707 watts into a 1 ohm load per channel, both channels driven into full power. Okay, we have a dirtier output signal.
So that's it for now. I hope you all enjoyed the video. Let me know in the comments if you have further infos about this nice amplifier. This amp made a good job. Thank you very much for watching this video and see you next time for one of the next ampdyno videos I'm showing up in my shorts. See you next time.